Video files are everywhere. We create them, download them, edit them, share them with friends, and play them back on a variety of different devices. Yet most of us don't know a lot about them and very frequently run into trouble. If you just want to convert a video to play back somewhere, or if you edit videos but have not dealt with the video file specifics yet, this overview might be helpful to you. The most important thing in the very beginning is a basic video file consists of 4 parts. Yes, that many. There is of course the video stream that contains information on what is supposed to appear on the screen during playback. Then there is the audio stream that holds acoustic content to be played back at the same time. As a third but very important part, we have metadata. This is stored information about the video and audio streams such as frame rate, bit rate and format, but also navigational or camera model context, and even subtitles. Last but certainly not least, all of this is packed together in a so-called container. The first thing we see when we look at a video file is the container, since it is represented in the file extension or folder structure. Yet this container format alone tells us very little about the content itself. And if a video file cannot be played back or imported into your editing software, this can be due to the used codec, in which case you will have to re-encode it, or simply due to an unsupported container, which you can losslessly change. So it's good to know a few things about containers. The currently most commonly used containers are AVI and WMV or ASF, developed by Microsoft, MOV, developed by Apple, MKV and OGG, which are open source, AVCHD, developed by Panasonic and Sony, and MP4, developed by the Moving Pictures Expert Group. Not every container can hold every type of codec, so you should choose your container format wisely. While the AVI container is still often used and widely known, it is very old and cannot hold more modern codecs like the popular H.264, so try to avoid it. The Windows-based containers WMV and ASF are not very flexible if used with anything but a Microsoft codec inside and cannot simply be played back on other operating systems. So you should try to avoid them too if you want to share the video with other people. Apple's MOV container supports virtually all codec formats and can be played back using QuickTime on all systems, so it is an option, but still a very Mac-based one. The open source containers OGG and especially MKV are highly flexible and can be used for sharing, but are sadly still not very well supported by editing software and some players. AVCHD was developed especially for consumer camcorders and is the only container format amongst these that does not store everything in a single file, but rather in a folder structure. Be very aware that if you delete the folder structure and only keep the MTS files, you are missing all the metadata information and will most likely run into problems when importing them into your editing or conversion software. Always keep the whole folder structure. You can already tell that this container is probably not very well suited for sharing or editing. Which leaves us with MP4. While it can also not hold a huge variety of codecs, it does support the most advisable compression format H.264, which we'll come to later. An MP4 file can be played back on almost all operating systems, mobile devices and standalone players, and is accepted by almost all video sharing websites. So that's the one to go with if you want to share your video with others. When it comes to editing, trust your nonlinear editing software to pick the right one and convert the imported files for you. If you have trouble importing, most software out there will accept MOV containers as input format. So what's inside your container once you open it up? Aside the metadata, we have 2 streams of information, both of which will most likely be compressed with some sort of codec. Codec just means compress, decompress, and it is meant to reduce the size of the content. This is very important, since uncompressed full HD video would take up around 400 GB per hour of film, and our hard drives are not really there yet. While there are some compression procedures out there that do not affect the quality of the footage, they don't reduce the file size by a significant enough amount, and most usable codecs will come with a loss in quality, so it is important to know a thing or two about them. For audio, the choice of compression is not as crucial, since even uncompressed audio data is not as huge compared to its video pendant. The most common uncompressed formats are WAV and AIF, both of which can be used for editing by any software. For distributing your videos, you can save some space by choosing one of the lossy audio codecs. The most common ones are MP3, AAC, and AC3, all of which are widely supported and can be used. For normal tasks, a bitrate of 96 kilobits per second in channel should be enough not to show the compression. For a stereo signal, this will be 192 kilobits per second. With video, there's a multitude of codecs out there, and describing them all would easily get out of hand. For video editors, the most important distinction has to be made between intraframe and interframe codecs. Simply put, an intraframe codec will take each single frame in the video and compress it, for example with a JPEG algorithm. An interframe codec, on the other hand, only saves one complete compressed frame every few seconds, and in between cleverly saves changes in the image, like big areas that stay the same, moving objects, or even camera pans. That way it can reduce the file size a lot more than an intraframe codec. It should be obvious that if you use an interframe codec for editing, this will mean a lot more work for your computer. When you want to jump to or cut at a certain frame, it will have to search for the first complete frame before this one and then calculate all the interframe changes since then to show you the resulting picture. This means that interframe codecs can be used to edit video, but they are a lot heavier on your CPU load and will not let you work as quickly. A rule of thumb can be that if you are short on disk space and you only want to do a few simpler edits, or if you work on a project with lots of multicam clips, an interframe codec could be beneficial to reduce the file sizes and the bandwidth from the hard drive. If you can spare the disk space, or if you want to do some more complicated and fast-paced editing, you should go with an intraframe codec. Of course, for video distribution, interframe codecs are preferred, since they are much less storage intensive. The most common intraframe codecs are ProRes on Apple systems and DNx HD within the Avid software. Both can be automatically converted on import into the software. There are countless interframe codecs, 3 of which shall be mentioned here. MPEG-2 was and still is the standard for video on DVDs. It is also recorded in by some consumer camcorders. DivX and slight variations of it advanced further in the field and are still used in many a downloaded video. The newest iteration of this trend, however, is H.264, sometimes referred to as MPEG-4, and DivX has no advantage over this codec, so it should be avoided wherever possible. There is already a successor on the way by the name H.265, but it is not here yet. So unless you have to deliver MPEG-2 for DVD, the best codec to distribute in currently is H.264, since for a given file size it provides the best quality. To simplify and sum up, remember to distinguish between codecs and containers. For editing video, try to stick to a ProRes codec and a lossless audio codec like WAV or AIF in a MOV container. For playing back or distributing video, use an H.264 codec with MP3 or ACC audio in an MP4 container.